So this is session 5 of the P6 unit on radioactive materials for OCR 21st Century Science. And so far we've looked at alpha and beta decay, and now we're going to look at gamma. So gamma radiation. Now gamma you should know about already from the unit we studied before on P2, which is about the EM spectrum. And what happens in gamma decay is that gamma decay normally accompanies an alpha or a beta decay. If you think that an unstable nucleus has to get rid of particles, it's essentially getting rid of some energy in order to become more stable, to reach a lower energy state. Now an alpha particle or a beta particle takes a certain amount of energy. Now there may be a smaller amount of energy to get rid of, which isn't the same as that contained in alpha particle or beta particle decay. So a gamma ray can be given out, if you like, in small amounts. So gamma radiation always normally accompanies alpha or beta decay, rather than being just on its own, although that can happen as well. So because it's radiation, it's a photon, so it's not a particle. So remember, it's a photon, so it has no mass at all, and it's just purely a photon or a bundle or a lump of energy that's given out. Now, because gamma radiation has no mass, it means that its range in air is quite significant. That's going to be many meters. And obviously we get gamma rays coming from all over the place, and they can travel a long way. So they travel a long way in air. To stop them is quite difficult because they are not particles. So they need to be stopped by very thick lead or several meters of concrete. Now then, their ionizing effect is actually very weak. Because they're not particles, they're not such great ionizers. And again, charge, there's no charge at all because it's an EM radiation or a photon. Okay, so not a huge amount of detail on gamma rays, simply because we've looked at gamma before and we know about its uses. So gamma is a high energy EM radiation. Remember, if you think of the EM spectrum, gamma ray photons have the most energy of all the photons in the EM spectrum. Again, gamma rays have got lots of uses, particularly for sterilizing, because gamma rays ionizing radiation has ability to kill living cells. So you can use gamma radiation for killing bacteria on food. You can use it for sterilizing surgical instruments, or in some personal hygiene products that need to be sterilized. You can seal the product from air, and you can expose it to the radiation, which passes through the seal packet to kill any bacteria that's in the packet, which means that things you wish to be completely sterile will be. Since 2010, irradiation has been permitted in the UK just for use on herbs and spices, but in other countries it's used for other sterilising other foods as well.